This is what you were presented with before clicking on our video. You had a choice, clicking on this one or a dozen others. YouTube doesn't just randomly show videos, it uses a sophisticated recommendation system to do so. But what you may not know is that there's a misconception about YouTube success. The gurus are lying. Recommendation systems like that of YouTube are extremely complex. No one, and mark my words when I say this, no one can understand them. So, people create narratives. This is the South Pacific. It's World War II, and indigenous peoples see the advanced military forces of the Allies receiving supplies and goods from the sky delivered by aircraft. Not fully understanding the technology or the global logistics involved, some of these communities began to mimic the outward behavior of the soldiers, like creating makeshift runways, wearing headphones made of wood, and crafting control towers from bamboo, hoping to attract the cargo themselves. They believed that these actions, which superficially resembled those of the military, would bring them the same rewards without understanding the underlying mechanisms. This is called the cargo cult, and a link can be drawn to YouTube. Much like the cargo cults, people, small YouTubers, see the success of their popular counterparts and attempt to mimic the visible aspects of that success, believing these actions are directly responsible for attracting the cargo, in this case, views and subscribers. Gurus will tell you it's about hacking the algorithm, but rarely anything else, without understanding what their words actually mean. By positioning themselves as the gatekeepers of the secret knowledge to YouTube success, they attract what they want, the views. That's it, and that's all that matters to a lot of them. People believe them because of a mix of desperation and the allure of easy success. It's classic human psychology, looking for shortcuts to success. Plus, there's a bit of confirmation bias at play. When someone follows an advice and sees even a slight improvement, they attribute it entirely to the advice, not considering other factors like changes in viewer behavior, seasonal trends, or just plain randomness. YouTube itself has said the recommendation system is based on machine learning, which means it learns and adapts over time based on user behavior. It's not a static set of rules you can just crack once and for all. Outsmarting some of the most sophisticated AI technologies developed by some of the smartest engineers and data scientists in the world is a myth. So I'm not gonna go down that path, as the answer to success on YouTube is quite obvious. Just make enough good videos. Now, although you cannot crack the system, you better understand the game you're playing. And that's why this video exists. It all goes back to the concept of choice. Check these two videos. What's happening is simple. The one on the left is yours, and the one on the right is, well, Mr. Beast. A viewer will be presented with these two videos and will have to make a choice. They can choose you or Mr. Beast, not both, because if they choose you, they cannot watch Mr. Beast, and vice versa. Therefore, because they cannot watch both videos at the same time, you draw a conclusion. Your video is competing with Mr. Beast for the viewer's available time. And see, while this may be true to some extent, well, watch this. This is what we call candidate generation. The true competition is the one you cannot see. And it happens way before a video lands on this page. There are two main ways to do this: content-based filtering and collaborative filtering. Content-based filtering is the one most of us know. Say you've been watching a bunch of music documentaries. The system will catch onto your interests in music and start recommending similar videos, maybe more documentaries on artists or the industry. classic. But then comes collaborative filtering. This one is more about connecting users with similar tastes. So if you and another user, let's call them Emma, have been watching similar types of videos and Emma likes a particular video, the system might suggest that same video to you. It's all about finding patterns in what different people watch and like. Now, here's what's interesting. These two methods overlap. They use something called an embedding space, where both the videos and our preferences are converted into these mathematical vectors. It helps the system make sense of our complex viewing habits in a simpler way. The closer these vectors are in this space, the more similar the videos or preferences. The system then uses different ways to figure out how similar videos are to each other. There's cosine similarity, dot product, and Euclidean distance. Each of these is like a different way to measure how close or relevant one video is to what you've watched or liked. Cosine similarity, for example, is great for seeing if two videos are heading in the same direction in terms of content or what users generally like. But here's the tricky part. Depending on which method they use, the recommendations can really change. Take the dot product. In the context of recommendation systems like YouTube, vectors often represent items like videos or user preferences. These vectors are not just directions, their length or magnitude can carry meaning. For instance, the magnitude of a video's vector might represent how often it has been interacted with, views, likes, etc. Popular videos, having been interacted with more frequently, might end up with larger magnitudes. And here's where the dot product comes in. Remember, the dot product involves multiplying corresponding elements of two vectors and summing these products. So if a vector has a larger magnitude due to a video being very popular, when you do the dot product with a user's preference vector, the resulting value might be higher. This can happen even if the direction or the actual content preference alignment isn't a perfect match, and that's a problem. Because you've been watching a lot of music documentaries recently and you want to keep on watching them, your preference vector might align well directionally with a few music documentary vectors. However, if a very popular but only somewhat relevant video comes along, its vector's large magnitude could result in a higher dot product with the user's preference vector, leading the system to recommend the popular video over the more relevant niche documentaries. And that's where it becomes interesting for you, because there's this thing we talked about, cosine similarity. For you as a creator, cosine similarity can be a big deal. It means that YouTube's algorithm has a way to recommend your videos based on how closely the content aligns with a viewer's interest, regardless of how many views or likes you've got. So even if you're a smaller channel, if your video is a good match content-wise with what certain users are into, there's a good chance it'll be recommended to them. In other words, cosine similarity levels the playing field. It's not just about promoting what's already popular. It's about finding that niche audience who will really appreciate your content. So focusing on creating content that truly resonates with your target audience, even if it's a smaller group, could actually work in your favor in terms of getting recommended. So now we know that you can be really successful with any type of content on YouTube, but now what? Well, there's still a major problem. Calculations like cosine similarity and dot product are very powerful in understanding linear relationships in data. But you, me, and the billions of other users on the platform are extremely complex, and our behavior is everything but linear. These are neural networks. They're one of the last layers, the core of what people like to call the algorithm. You don't understand them, but I don't either, and neither does YouTube. So no, there's no cracking the algorithm, revealing the algorithm, or anything of the sort. But you can still use those for your success. You see, these neural networks process about 80 billion multi-dimensional and highly dynamic hidden factors. Understanding precisely which factor plays a more significant role is nearly impossible. But the reason they are so effective, yet so hard to comprehend, lies in their learning process. They use something called backpropagation, where they constantly adjust their internal parameters based on the accuracy of their predictions. But again, the learning is not explicit. YouTube cannot easily interpret what each neuron has learned, which adds to the complexity. And then, to make it even more complex, there's the aspect of personalization. YouTube's algorithm isn't just trying to understand content. It's, as mentioned previously, trying to understand individual users. Because it's one thing to categorize videos into genres. It's something completely different to predict what a specific person wants to watch at a specific time. This involves understanding user behavior, which is highly unpredictable and varied. So what? How can you use them if no one understands them? Well, simply do what YouTube does. Understand the outcome. YouTube provides input, in this case the millions of videos, and expects a prediction in line with their goal, which is quite simple.
They're paying $1.65 billion, £900 million, which is an astonishing sum of money when you consider that YouTube was only created in February of last year.
Why is Google so determined to get it, and why is it paying so much money for it?
Well, it's a very good question, because YouTube actually makes no profit at all. It's for the advertising potential, which it thinks is enormous.
If you made it through this segment of the video, you're probably already aware that YouTube's revenue model is based on advertisers.
Tending a garden can be hard work, especially when you're in the golden years, like me. That's why I use organic glue.
The more ads are seen by the users, the more money YouTube makes. So the desired output should be in line with that, meaning the network's output should result in simply increasing the platform's average watch time. This is what matters to YouTube, nothing else. So the question you should ask yourself is simple. Will my video increase YouTube's average watch time? In other words, will enough people enjoy watching my video or not? So no, it's not about luck, it's about you aligning with YouTube's goal. If you do, you'll find YouTube success. You don't exactly get picked up by the algorithm. It's either you align or you don't. And that's the reason why there's this thing everyone likes to talk about. I'm pretty sure you've heard about consistency many times. And you were told that if you stayed consistent, meaning you posted videos regularly for a long enough period of time, your videos would eventually be picked up and you would get a ton of views. And it's not bullshit, but poorly explained. YouTube doesn't care about how consistent you are with your uploads. Because, as I said, it's all about aligning with their goal. And consistency doesn't directly do that. But there are two reasons why it still helps. First, and most evident, is, well, most people are terrible at making videos, so they can't align. Staying consistent will help with that. The skills will improve, from storytelling to editing and marketing, especially with helping you to position yourself better. On YouTube, this might be your speaking style, editing, rhythm, music choice, or the angle with which you approach your topics. YouTube, more than any other platform, is driven by this need for unique content positioning. But it serves another purpose. From the beginning of this video, I somewhat led you to think that you could explain most things and use what you understand to your advantage. But that's wrong. Because, yeah, there is a space for randomness, a space for what some people would like to call luck. External factors do exist. These neural networks I was talking about are highly unpredictable, ever-changing as they always take into account new and external data. And unfortunately for you, you cannot do anything about it. Here's where statistics and probabilities come into play. There's a thing called the law of large numbers. This tells us that as you increase the number of trials, the average of the results gets closer to the expected value. In probability terms, you're reducing the variance, which is a measure of how spread out your results are. A high variance means your videos are all over the place in terms of performance. Now, a low variance implies consistency in performance. What does this mean for you? Well, the more you upload, the more data points you create. It reduces the impact of outliers, those random videos that either do unexpectedly well or unexpectedly poorly, which we might call luck. By regularly uploading content, you're helping to stabilize and get closer to the desired goal of aligning, which is almost impossible without consistency. So yeah, this analysis, while complex, helps with the key takeaway: the extreme complexity of recommendation systems like YouTube and our tendency to create narratives to understand it. As a content creator, focus on offering the best content possible. Of course, this video doesn't give exhaustive detail when it comes to being a good YouTuber. There are many concepts of a good video that I haven't covered, because these can be subjective depending on the topic, audience, and many more. But I hope it helped you understand the rules of the game a little bit better.